Hey guys, welcome back to Math from my desk, and in today's video we'll be solving this limit right here. So the limit as x approaches 0 from the right of x to the power of x. The reason we're not evaluating the global limit is because when you approach this function from the left, you are no longer in the realm of real numbers, you're entering the set of complex numbers, and we don't want to go ahead and deal with that. So if you do direct substitution, what you end up with in here is 0 over 0, which obviously this is an indeterminate form. So we're going to have to figure out some other way to solve this problem right here. And the first thing you should recognize or note is that x, this is equal to e to the natural log of x. And so x to the x is equal to e to the natural log of x to the power of x, which is just equal to e to the x times the natural log of x. So we can go ahead and rewrite this limit right here. So we end up with the limit as x approaches 0 from the right of e to the x times the natural log of x. Now let's see how x to the natural log of x behaves when x approaches 0 from the right. So obviously x right here is going to go to 0, and the natural log of x, well, you recall that the graph of the natural log, it looks something like this. So as you approach 0 from the right, it's going to go to negative infinity. So you end up with 0 plus times negative infinity, and obviously this right here is also an indeterminate form. So now we had two different indeterminate forms, so we need to go further. And the next step is basically we're going to go ahead and evaluate x to the natural log of x as its own limit. And because this function is continuous, one of the properties of limits is that you can change this right here to be e to the power. Actually, let me write it neater down. You can change this limit to be e to the power of the limit as x approaches 0 from the right of x times the natural log of x. This is something you can do once again because this is a continuous function. This is one of those properties of limits that you should have covered in Calc 1. So now we're going to go ahead and focus on this individual limit right here. So let me go ahead and rewrite it. So we have the limit as x approaches 0 from the right of x times the natural log of x. And as we showed before, this is going to head, if you do direct substitution, this is going to go to an indeterminate form, 0 times negative infinity. Now, the trick for this, basically what we're going to try to do, is we're going to rewrite this function in a way that allows us to use L'Hopital's rule. And how are you able to use L'Hopital's rule? Well, if you get an indeterminate form of plus or minus infinity over infinity, or 0 over 0. And you can go ahead and obtain that indeterminate form if you rewrite x times the natural log of x, if you rewrite it as the natural log of x divided by 1 over x. If you divide the natural log of x by 1 over x, it's the same thing as multiplying it by x. And so if you do direct substitution here, as we figured out before, the natural log of x as x approaches 0 from the right, that's going to go to negative infinity. And then 1 over x as x approaches 0 from the right, that's going to go to infinity. So you end up with an indeterminate form that allows us to use L'Hopital's rule. So we're going to go ahead and use L'Hopital's rule now. So L'Hopital's rule tells us the limit as x approaches 0 from the right of the natural log of x divided by 1 over x is equal to the limit as x approaches 0 from the right of the derivative with respect to x of the natural log of x divided by the derivative with respect to x of 1 over x, which is equal to the limit as x approaches 0 from the right of, well, the derivative with respect to x of the natural log of x, that's just 1 over x. And then the derivative with respect to x of 1 over x, that's negative 1 over x squared. And we can go ahead and simplify this expression right here by multiplying both the numerator and denominator by x squared. So in the denominator, you just end up with -1. And in the numerator, you end up with x. And so what you end up with is the limit as x approaches 0 from the right of x divided by -1. All right, so this is the simplified limit. Now we're going to go back to our original expression. We wanted to evaluate this right here. So we end up with e to the power of the limit as x approaches 0 from the right of x divided by -1. And obviously this is really easy to solve. You just go ahead and do some direct substitution. You have 0 over -1, which is obviously 0. So you end up with e to the 0, which ultimately is equal to 1. And this right here is the solution to our limit. So the limit as x approaches 0 from the right of x to the power of x is equal to 1. And that's it for today. Thank you guys for watching. Please like and subscribe, and I'll see you soon for another video.